Welcome students to today's session. After studying about pure substance and mixtures in the previous session and differentiating between homogeneous mixture and heterogeneous mixture, we shall study about the different types of mixtures in this session. We have three different types: true solutions, suspension, and colloids. A true solution is a homogeneous mixture of two or more substances. Solution has a solvent and solute as its components. The component that is larger in amount is the solvent, and the component that is lesser in amount is the solute. Solution of water and salt, solution of sugar in water, iodine and water are examples of true solution. Let us look into the properties of a true solution. A true solution is a homogeneous mixture. The particles cannot be seen by naked eyes. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable. The particles do not scatter a beam of light passing through it. That is, it does not show Tyndall effect. Next one is colloidal solution. Colloidal solution is a heterogeneous mixture of two or more substances. Like examples, mixture of starch in water, mixture of egg albumin in water, milk in water, air containing dust or smoke. These are all examples of colloidal solution. Let us see what are the properties. A colloidal solution is a heterogeneous mixture. The particles cannot be seen by naked eye. The solute particles cannot be separated by filtration. The solute particles do not settle down and the solution is stable, but the particles scatter a beam of light passing through it, and the path of light becomes visible in the solution, which is known as Tyndall effect. Colloidal solution show Tyndall effect. Next one is suspension. Suspension is a heterogeneous mixture of two or more substances. Solution of sand in water, solution of chalk powder in water, etc. Let us look into the properties of a suspension. Suspension is a heterogeneous mixture. The particles can be seen by the naked eye. The solute particles can be separated by filtration. The solute particles settle down and the solution is unstable. Here also, the particles scatter a beam of light passing through it, that is, the path of light becomes visible in the solution. Let us look at these properties of suspension. The first one is the solute particles can be separated by filtration. Solute particles settle down and is unstable. You can see the settling down of sand below in the beaker. The next picture shows you Tyndall effect, that is scattering the path of light through solution. The path of light becomes visible. Scattering of light takes place by the particles present in the solution, and this phenomenon is called as Tyndall effect. Let us study Tyndall effect in detail. In nature, Tyndall effect is seen when light enters through a narrow hole into a dark room. The path of light becomes visible, and what makes it visible is the particles present in the room or in the atmosphere, as seen in the next picture. The first picture, in the room, the dust particles present in the room scatter the light ray and the path of light becomes visible. If it is a forest, it is the particles of mist which scatter the rays of light. The mist that is suspended in air scatter the rays of light and the path of sun's rays become visible in the forest. This is called as Tyndall effect. When a beam of light is passed through a colloidal solution, the colloidal particles scatter the beam of light and the path of light becomes visible in the solution. This effect is called Tyndall effect. Tyndall effect can be seen when light enters a room through a small hole due to scattering of light by dust or smoke particles. The effect can also be seen in a dense forest due to scattering of light by water droplets present in mist. Let us look into solution of a certain concept which called as how to find out concentration of a solution. Concentration of a solution is the amount of solute dissolved in the amount of solution. There are two ways of methods of expressing the concentration of solution. The first one is by calculating mass by mass percentage of solution. In this, you have to use the formula mass of the solute divided by mass of the solution into 100. If it is mass by volume percentage of a solution, then you have to use the formula mass of the solute divided by volume of solution into 100. Let us solve a problem which is related to this concept. A solution contains 40 grams of common salt in 320 grams of water. Calculate the concentration in terms of mass by mass of the solution. It is mass by mass of the solution, so we will apply the first formula, mass by mass percentage of a solution. Mass of the solute is 40 grams, mass of the solvent is 320 grams. Mass of the solution is total 320 plus 40 grams, which is 360 grams. Mass by mass percentage of solution is mass of the solute divided by mass of solution into 100, which is 40 divided by 360 into 100 is equal to 11.1%. If the problem gives you in terms of volume, then you have to use the second formula, mass by volume percentage of a solution. With that, today's session comes to an end. Please go through and complete the work allotted. Thank you.